KCET 2025 aspirants. So in today's video, we are going to solve the top 30 questions from the chapter Electrochemistry. This is a very high weightage topic and you can easily expect 3 to 4 questions from this chapter. Let us move towards the first question here. 4 colorless salt solutions are placed in a separate test tube and a stripe of copper is placed in each of them. Which solution finally turns blue? So now you see that copper is placed, you are placing copper in different types of solution. The metal which is more reactive than copper can displace copper, right? The metal which is more reactive than copper can, you can see here, one second. I'll draw it and I'll tell you. So we are having here metal solutions and you have dipped a copper strip, right? So now, if copper, not the metal, if copper is more reactive than metal, if copper is more reactive than these metals, right, then copper can displace this metal and copper nitrate solution will form and the solution will turn blue in color. So if you remember that copper is more reactive than silver, okay, so that means what? Copper can displace silver from the solution and it will turn blue, so that is why option number C. You can see the reduction potentials given here. Next, a half cell reaction A minus to A plus electron has a negative reduction potential. Negative reduction potential means it has the tendency to get oxidized, so option number B. Next, the charge required to deposit 9 gram of aluminium from Al3 plus solution. So if you remember, aluminium reaction is how? Al plus 3 electrons gives aluminium, right? So 27 gram is deposited by 3 Faraday, 1 gram will be deposited by 3 by 27 Faraday, 9 gram will be deposited by 3 by 27 into 9 Faraday. That means 1 Faraday, which is equal to 96500 Coulomb. Next, EMF for the reaction is given, then we have to calculate the delta G for this reaction. Very simple. So you can see that if I have copper to copper 2 plus 2 electrons. So this is when 1 mole of copper is there, I need 2 moles or 2 Faradays of electron. If I have half moles, then I will require 1 Faraday. So I can say that N is equal to 1 here. Okay, so we have to calculate what? Delta G. Delta G. So N is equal to 1 because it is half mole, 96500. So what is the formula? Delta G is equal to minus NF E naught of the cell. So minus 1 into F into E naught value is 1.02. So if I multiply this one, it will become minus 96500. So already I can eliminate these two options. It will be somewhere near to this one. Okay. Next, a student of 10 plus 2 made the following observations in the laboratory. You can see copper metal did not react with lead nitrate, means copper was not able to displace lead. So I can say that lead is more reactive than copper. Next, lead metal dissolved in a AgNO3 solution and Ag metal is crystallized out. That means lead was able to displace silver, so lead is more reactive than silver. Okay. Next, silver metal did not react with copper. That means copper is more reactive than silver. So what is the order of reactivity? We have to arrange them in the decreasing order. So I will have lead first, then copper and then silver. So option number D here. Next, electrolysis involves the oxidation and reduction respectively. So oxidation is always at anode and reduction is always at cathode. Option number A. Easy question this one. The charge required for the oxidation of 1 mole of FeO to Fe2O3. So if you see here FeO2, Fe2O3. So I have here charge is plus 2, here the charge is plus 3. You require 1 Faraday, but here I have 2 Fe2O3, means 2 times Fe is there. So this also will be 2. So it will be 2 Faraday, option number B. Next, for measuring the electrolytic conductance, one must use conductivity water. Okay. The potential of hydrogen electrode having a pH is equal to 10. So this is a good question from NCERT exam, NCERT book only. So we have the reaction like this: 2H plus 2 electrons gives you H2. Right. Now E of the cell will be equal to what? E naught of the cell, hydrogen electrode potential is 0, minus 0.059, I will write it as 0.06 divided by N is 2 log of 1 by H2 and H plus concentration square, right? So if pH is equal to 10, then what is H plus concentration? 10 to the power of minus 10. So I will get 0.03. Okay, so let me let me keep it as 0.059 only, because I can see the options here. So you will get here 0.059 by 2, and this is log of 1 by 10 to the power of minus 10 square. Minus 20, this will go up, so 0.059 by 2 log of 10 to the power of 20. So 20 will come here, 2 into 20 you can cancel, so you will get minus 0.59, that is option number B. Next, in an experiment, 0.04, this is a good question. 0.4 Faraday was passed through 400 ml of 1 molar solution of NaCl. What would be the pH of the solution after the electrolysis? So if you have remembered electrolysis of NaCl plus water, what were the products we used to get? We used to get NaOH plus half Cl2 plus half H2, right? Now if I see just Cl minus, right, Cl minus gets converted to half Cl2 with 1 mole of electrons, right? So I can say that 1 mole of electrons deposits 1 mole of NaOH, right? So 1 mole of electrons, which is equal to 1 Faraday, deposits 1 mole of NaOH, right? So 0.04 Faraday will deposit how much? 0.04 moles of NaOH, right? This is done. Now you have to calculate the concentration of OH minus, number of moles by volume. So number of moles is 0.04 and volume is 400 ml into 1000. So if I just calculate, I will get 0.1, that is 10 to the power of minus 1. What is the value of POH then? Minus log of OH minus. So that is minus log of 10 to the power of minus 1. So that is 1. What is the value of pH here? It is 13. Okay. So option number C. Next. For a cell reaction involving 2 electron changes, E0 value is given, then the equilibrium constant of the reaction is. Equilibrium constant of the reaction. So you can see here, E0 of the cell is equal to 0.059 by n log of K, right? What is the E0 value of the cell given? 0.3. Okay. This one I will write as 0.06 divided by 2 log of K. Now if I solve this, I will get 10 is equal to log of K. So K will be equal to 10 to the power of 10. That is option number D here. Okay. Next, in which of the following cases a chemical reaction will take place? So silver nitrate solution is stirred with a copper spoon. So if we know that copper is more reactive than silver, so copper will displace silver and copper nitrate will form. So reaction will take place in this case, so option number A. Next, in fuel cells, dash are used as catalyst, platinum and palladium are used as catalyst. Theoretical fact based question. This is an important question here. So you see that we have a reaction like this where Ag plus 1 electron is giving me Ag. Okay. So what is the E value? It will be E0 minus 0.059 by n, n will be 1 here, log of 1 by Ag plus concentration, right? So what I will do is, I will put the option wise each A, B, C, D, I will put the concentration and I will write the equation. So E is equal to, so for option A, E is equal to, what is the value of E0? E0 value is given to me as 0.8 minus 0.059 into log of 10 to the power of minus 4. It will go up, it will become 10 to the power of 4. 4 will be multiplied here, right? So into, I am not having space here, let me go down and write here, wait. For option number A, E of the cell will be equal to E0, that is 0.8 minus 0.059 by n, that is 1 log of 10 to the power of minus 4, so this will go up 10 to the power 4, so I will have 0.8 minus 0.059 into 4. Okay, that is my option number A. Similarly, if I just write down directly, I will get 0.059 into 1. Then here I will find 0.8 minus 0.059 into 2. And here I will get 0.8 minus 0.059 into 3. Right? So you are subtracting a number. Now see, this number is very big, so if you subtract, this value will become less. Here you are subtracting a smaller number, so this value will be big. So B, then C, then D, and then A. Option number C. Next, current of 3 ampere is passed through a molten calcium salt for 1 hour 47 minutes and 13 seconds. Mass of calcium deposited is. So this is very direct formula based question. So we know that for Faraday's law, M is equal to Z into I into T, where Z is equal to molar mass by N into 96500 into I into T. Right? So now what is your molar mass here? Molar mass is 40. For calcium, you know, calcium 2 electrons will be required, 96500. I is what? Current is 3 ampere, right? Now time. See, time was 1 hour 47 minutes and 30 seconds. So what I will do, 1 hour is 60 minutes, so 60 seconds, 3600. For this one, 47, for easy calculation, I will make it 50 minutes, okay, just round off. So 50 minutes into 60 seconds is again 3000, and then I have a 13 seconds left. So I will get 6613. So again easy calculation, I will round it off to 6600. Okay, now this 96,500 also I will round it off to, okay, 1 second. Okay, so this 96,500 I will round it off to 96,000 for easy calculation. So this 0, this and this all got cancelled. 4 ones are, and 96 is 24. Then I can cancel 3 ones are, 3 eights are. Then I can cancel 2 fours are 8, 2 33. So 33 divided by 8, right? So it will come 4 point something, because 4 eights are 32. Option number D. Okay, how easily you can do the calculation. Next, mercury cell does not give steady potential. In the cell reaction, ions are not involved in solution. So yes, ions are involved in, here you can see ions are involved, so reason is false. So we have only one correct answer, that is your option number C. Next, for measuring the resistance of an ionic solution, AC source is used. Concentration of ionic solution will change if DC source is used. So this was a theoretical questions that we have discussed many times before our board exam. So yes, both are correct, and reason is the explanation. Next, this is a good question. The specific conductance of 0.02 m. So I have concentration as 0.02 m. Solution of a weak electrolyte is given. Specific conductance means kappa, that is 3 into 10 to the power of minus 4. Degree of dissociation is 0.06. Its molar conductance at infinite dilution we have to find out. So first let us find out the molar conductivity, that is kappa into 1000 by C. Okay, so I will get here, this is as 15, right? Now what we have, alpha is equal to lambda m by lambda naught m, right? Now what I want to calculate, lambda naught m will be equal to lambda m, that is 15, and alpha value is 0.06. So if I solve this, you will get this as 250, that is option number D. Okay, so it is like 115 into 100 divided by 6. 3 2s are, 3 5s are, 2 1s are, 2 50s are, 250 you will get. Okay, next, 1 Faraday of electricity will deposit 1 gram atom, means 1 mole of metal from the solution of. So for deposition of gold, it is in +3, we need 3 Faraday. For deposition of copper, we need 2 Faraday. For deposition of barium chloride or barium, we need 2 Faraday. For silver, I require 1 Faraday, option number D here. Okay. Next, Nernst equation for the given cell. So if you see here, Fe to Fe2 plus, what is the equation? Final equation is like this, Fe plus Ni2 plus gives you Fe2 plus plus Ni, right? So in the equation you will have E naught of the cell minus RT by NF means 2F log of Fe2 plus concentration is 0.2 and Ni2 plus concentration is 0.1. Okay, so log 2 value, so we are not using 2.303, so this is ln. So E naught minus RT by 2F ln, that is option number B. Next, the correct statement regarding the electrolytic solutions are: the specific conductance of a weak electrolyte decreases and that of strong electrolyte remains constant with the decrease in concentration. No, there is no such reason here. Molar conductance of strong electrolyte decreases and that of weak electrolyte increases. No. For both strong and weak electrolyte, the molar conductivity increases. The velocity of the ions of the strong electrolyte increases with the decrease in the concentration. Yes, when we dilute it, the mobility of the ions increases in case of strong electrolyte. The number of ions produced increase in weak electrolyte due to the decrease in the concentration. Yes, the ionization increases, more number of ions are produced. So C and D both are correct here. Next, for a spontaneous reaction, delta G equilibrium constant of the cell reaction and E naught of the cell are respectively. Spontaneous reaction means delta G has to be negative, so eliminate these two, and E naught of the cell has to be positive, so eliminate these two. Option number D here. Next, according to Kohlrausch-Dahl, the limiting molar conductivity of the electrolyte is. So I have 2A, so there should be 2A, here I have, right? Then there is no half B, only B should be there, so option number D. Okay. Next, the pH of aqueous K solution is 7.0. The pH of the solution was electrolyzed for a few seconds using platinum electrode. Which of the following is correct? Now if you have aqueous solution, you will have H plus, OH minus, K plus and Cl minus. When the electricity is passed, what will happen? This H plus will get reduced, H plus concentration will decrease, so pH of the solution will increase. Next, two different electrolytic solutions filled with copper nitrate and molten aluminum nitrate respectively are connected to series. When the electricity is passed, 2.7 gram of aluminum is deposited on electrode. Calculate the weight of copper deposited on cathode. So this is your normal Faraday's second law question. We have here M1 by M2 is equal to equivalent weight of 1 by equivalent weight of 2. So I can write it like this: mass of, I want to calculate mass of copper deposited divided by mass of aluminum deposited is equal to equivalent weight of copper by equivalent weight of aluminum. So mass of copper, mass of aluminum, how much it is? 2.7. Equivalent is what? Molar mass by number of electrons used into 27 by 3. Now if I solve this, you will get mass of copper as 9.525, option number B. Next, when the samples of copper with zinc impurity is to be purified by electrolysis, the appropriate electrodes are. So here you remember always anode is taken the impure sample and cathode will be the one with pure sample. Okay, so that is D, cathode is pure copper, anode is impure sample. Next, what we have, the EMF of the cell is given. You have to calculate the value of equilibrium constant. So we have this formula: E naught of the cell is equal to 0.059 by N log of K. What is this E naught value? I think this is some error. It is 0.0295. This one, please correct it. 0.0295. Okay. Now what is the N value? Here N value is 2 divided by 0.059 is equal to log of K. So K will be equal to 10 to the power of this whole term. Now you can see in the denominator we have 0.059 and there is only one option with that. So option number D here. Okay. Next, the limiting molar conductivities are given. So for NaCl it is given as 126, then for KBr it is 152 and for KCl it is 150. Okay. So now if I just solve it, I want for KNaBr, right? So I have to add these two. So if I add these two, I'll get 6 plus 8. 278 minus 150, right? So how much I will get? 128. That is option number A. Next, the highest electrical conductivity of the following aqueous solution is, so this is somewhere related to organic chemistry as well. So wherever the conjugate base will be more stable, there the ionization will be more ions will be produced, electrical conductivity will be more. So where fluoroacetic acid, we have a electron withdrawing group, so that is why the conjugate base is more stable. Here the ionization will be maximum, so option number B. Last question. To calculate the nernst equation is given. So we have this equation, let us write down first what will be the reaction at anode. So we have Cr to Cr plus 3 electrons, then we have Fe plus 2 electrons, okay. Here I have 2 multiply, I will multiply 3 so that the number of electrons is constant. So I will have 2 Cr plus 3 Fe2 plus gives me 2 Cr3 plus 3 Fe. Okay, now I want to write the E naught of the cell, that is E naught of cathode minus anode. So cathode minus anode. So anode is minus 0.42 minus anode is minus 0.72. Okay, so I will get here 0.30. E naught of the cell is 0.30. Okay, next what I have, yeah, that's all. Let's solve it now. E of the cell is equal to E naught minus 0.059, so I will write it as 0.06. This number of electrons is 6 log of Cr3 plus concentration is how much? 10 to the power of minus 1, okay, to the power of 2 whole divided by Fe2 plus 10 to the power of minus 2 to the power of 3. Okay, so we will get here 10 to the power of 4, this one, so 0.3 minus 0.01 into 4. So I will get minus 0.04, so that is equal to 0.26, that is option number B. Okay. Yes students, so these were the top 30 questions that we have solved. So it is not that only numericals will be asked, you can have a lot of theoretical questions as well. So please prepare this chapter thoroughly, and if you have any doubt, please put down in the comment section, I will definitely address to it. So thank you for watching, and do not forget to subscribe our channel.